There is a very small video which I want to show to you. It is regarding subjecting air, water and carbon dioxide to a very low temperature, and let us see what happens to these fluids when they are subjected to very low temperature. Let us have a look at this video and then we can draw some conclusions from this video. So, here we are trying to put water in this PVC pipe, kind of a plastic, and this PVC angled pipe will be closed from both the sides, and then I will put this water in this PVC pipe in the liquid nitrogen bath. Liquid nitrogen, as you know, exists at minus 196 degree centigrade or about 77 Kelvin. This is liquid nitrogen which will be transferred from a specially made container of liquid nitrogen into a thermocol container. You can see that it looks like water only and it is getting evaporated. I will put this PVC sample filled with water in liquid nitrogen. Let us wait for some time. You can see liquid nitrogen boiling vigorously, and what you see is a very important thing now, and if you could observe that this material of PVC has got cracked. Obviously the water inside this has got frozen and you can see ice everywhere, outside also, and what you see here also inside is ice, but noticeable is the fact that the cracks on this pipe. In fact, if you spend for some time, this will get, there can be a small explosion also. Okay. Let us repeat the same experiment now using air as a medium, and also we can have CO2 gas as a medium. So, here again I will take carbon dioxide in a balloon, which you can see, and this balloon is now put in liquid nitrogen, and now you can see that the balloon is getting shrunk, and what you see now is the CO2 gas now has become solid also. What you see now is solidified CO2, and you can see the solidified powder here of CO2. CO2 solidifies around minus 80 degree centigrade, and now I can just show you the solidified CO2 powder which you can see here. Now I am taking air instead of CO2, I will take air in the balloon, and this balloon then again will be subjected to 77 Kelvin or minus 196 degree centigrade. Air has boiling point of 78 Kelvin, and you can see that this air, gaseous form air, will get liquefied when it is put in liquid nitrogen. Also you can observe the shrinking of this balloon as the temperature of the air decreases. Alright, the volume will decrease. So you can see inside this some amount of liquid that has gathered over there. This is liquid air, alright, because it was subjected to temperature which is lower than its boiling point, the air in this balloon got liquefied. So what is noticeable in all this thing is, when we had put water in this angled pipe, the pipe got cracked because after freezing there were stresses generated inside the pipe. That means the frozen water actually increased its volume. So this is basically what you see is a PT diagram of water, and what is important to notice is that water expands on freezing. This diagram is meant for water, where we notice that this is the solid to liquid conversion or liquid to solid conversion, alright, solidification or freezing that happens across it. And here what we see is that this curve is what we call as SL curve. This is tilted on the left side. If I draw a vertical, this is tilted on the left side, and this is for all the substances that expand on freezing, alright. So, you have seen that water, because it expanded after freezing, this angled PVC pipe cracked, while it did not happen the same for CO2 or for air. And CO2, you can see that the PT curve for CO2 in this direction. So, this line, which actually makes an angle on the right side of the vertical, it is for those substances that contract on freezing, which is where carbon dioxide, it contracts on freezing, and because it contracted on freezing, there was no problem to the balloon that we had. While as far as water was concerned, because it expanded after freezing, it produced cracks on this angled PVC pipe. This is just a small video to give you some food for thought, and what I believe is basically you can find its mathematical explanation in terms of dP by dt, pressure change with temperature for both water and also for carbon dioxide and also for air. You can treat this experiment and this slide for additional learning of these properties of fluid. Thank you very much.